This is my attempt to explain blind signatures. About a year ago, I did a video on pairing cryptography and the proofs that you could do with pairing cryptography. So here's a video where I'm trying to explain blind signatures and why they are so important and powerful. So let's work through it. So you have a bank, and what they do is they publish a public key of K, which is actually their secret key, which is a small lowercase k multiplied by a generator point, where K is secret and G is a generator point. And keep in mind, I'm using the notation, additive notation for public key cryptography. And the idea here is that this is the public key as a point, that's a random number, that's a point on the curve that everybody agrees on, and when you multiply it, you get a value, which you can't actually figure out what K is from that. So the first thing, what happens is that Alice chooses X, which is a secret, and she creates a point Y by a function called hash to curve and X. There's a function that takes whatever the arbitrary value of this is, typically a digest, SHA-256 digest. An algorithm will actually come up with a corresponding curve point, which is actually denoted by the capital Y. So the idea here is that this is a point that can only be generated if you know what X is. The next thing that she does is actually chooses R, a random number, or which is used once, and that's called a nonce. And she calculates the blinding payload, if you will, and that's T. It's another point, and basically it's Y plus the random number multiplied by the generator point. So she comes up with T. She sends T to the bank. So the bank receives T and signs it with its secret, which is K, the lowercase k here, and sends back to Alice this value of Q, which is actually K times T. And again, Alice gets this Q, but she has no idea what the numbers are behind it. And again, that's due to the discrete logarithm formula. So Alice receives Q, and then she unblinds it. So what she does, she calculates a Z. And Z is basically Q. She takes her random number again that she generated in the previous step and takes the public key of the bank and calculates Z. And this is pretty difficult to understand. It took me quite a while to actually understand what was going on here. But the idea here is Z is actually, if you start substituting, Z is KT minus RK. And when you start doing the calculations, T was Y plus RG up here, multiplied by K, minus if you actually take R, and the public key is actually K times G, which is up here. You do the math and you expand it, and then you notice that these intermediate terms actually cancel out, and Z is equal to KY. In effect, what this is saying is that this is the signature for the secret that the bank could not see, that was actually blinded up in this step here in step 2. So then what Alice uses as a proof to the bank, she provides X and Z. And the bank, to verify that indeed this was the same X which was signed with the blind signature, takes X, does a hash to curve, multiplies it by K to arrive at the number Z. And if that number, excuse me as my camera gets out of focus, if that number, that hash to curve X times K equals Z, which is provided in the proof, that means that that was actually signed by the bank. It takes a while to figure this out, to understand it, but the idea here is that the bank can actually sign something, or any issuing institution, and when that secret is provided later on, sometime in the future, the Alice can actually prove that it was that value that was signed by the bank, but the bank did not actually know what it was to begin with. And this is the basis of what's called Shawmian Mint, the ability to issue notes and enable people to distribute notes or cash bills or e-cash without actually knowing who it was issued to, or when it actually gets redeemed, tracing it back to the original holder of the note. So there we go. I hope that explains it. It's a bit, it takes a while to understand, but this capability of doing what's called blind signatures is like super duper powerful in creating some new capabilities.